All right, so in this video, we're going to find the average value of a function. And in 2 dimensions, the formula for the average value of a function looks something like this. We're going to need to integrate over some interval, and then we're going to divide essentially by the length of the interval. Now, there is a 3-dimensional equivalent to this. So the average value of a function in terms of x and y is going to be 1 over the area rather than the just the length of an interval. And then we're going to do a double integral. A to b and f of x, g of x, f of x, y, dx. So essentially we're finding the volume, and then we're dividing it essentially by its footprint, which is the area it's integrating above. And the area itself is essentially g of x minus f of x. So it's the area in the plane. All right, so let's go ahead and do the 1 variable case, and then we'll go ahead and do the 2 variable case. So let's consider the function f of x is equal to 6 minus x cubed. And we want to find the average value of the function on the interval -1 to 1. All right, so our average value is going to be, our interval length is 2 because it's 1 minus a minus 1. And then we're going to integrate from -1 to 1 of 6 minus x cubed. So we're going to get 1/2. And when we do our antiderivative, we get 1/4 x to the 4th from -1 to 1. And so let's plug those things in. So 6 times 1 minus 1/4 times 1 to the 4th is 1, minus 6 times -1 minus a minus will give me a plus. 1/4 -1 to the 4th is also 1. So that means this term and this term are going to cancel, but minus a minus is going to mean these 2 terms are going to add up. And so I'm going to end up with 1/2 times 12, which is equal to 6, which should make sense for this particular interval. It's going to be a little higher than 6 on the one side. It's going to be a little lower than 6 on the other, but they're going to increase and decrease because of the symmetry of this function on either side of 6. And so that is a reasonable expectation. Now, for the multivariable case, let's consider the function f of x, y is equal to x squared minus y squared. And just for the sake of simplicity, we could make this a rectangular region. But I think I'm going to try to make it triangular just so that it's a little bit, it's not completely obvious that we should be thinking of A as always a rectangle. Again, just for the sake of generalization. So let's say over the region in the plane bounded by let's say 0 less than or equal to x less than or equal to 2, and 0 less than or equal to y less than or equal to x. So the region in the plane that we're talking about here is essentially a triangular region. It's 0 to 2 wide in the x direction. The top function is y equals x. And so this will be a triangle. So let's go ahead and calculate the area of our region. Now we can set this up as a single variable interval, which would be the function y equals x and then minus 0, because that's the bottom of our function. Alternatively, we could also set this up as a double integral, 0 to 2, and then 0 to x of dx. Since we're just finding the area, we're not integrating any function at all. But these are completely equivalent to each other. When I integrate 1 and then I substitute, dy dx. When I integrate y with 1, I'm going to get just y, and then I'm going to plug in x and 0, and I'm going to get x minus 0. And then the second step of the integration is going to be exactly the same. I'm going to integrate x, and I'm going to get 1/2 x squared. And I'm going to integrate that from 0 to 2. Which is going to give me 2 squared is 4, divided by 2 is 2. So the area of this triangle is 2. And this makes sense if you think about 1/2 base times height. It has a base of 2 and a height of 2, and then half of 4 would be 2. So geometrically, this all makes sense. So now we're going to go ahead and find our average value of our function. And so 1 over our area is going to be 2. And then we're going to integrate the function. Notice the area didn't have anything to do with the function. But now we're going to integrate our area 0 to x of x squared minus y squared dy dx. Now, if I integrate with respect to y first, then I'm going to get x squared y minus 1/3 y cubed evaluated between 0 and x and when I plug in x, x squared times x is going to be x cubed minus 1/3 x cubed minus 0. And 1 minus 1/3 is going to be 2/3. And the half and the 2/3 are going to cancel, and they're going to give me 1/3. 0 to 2 of x cubed. And so I'm going to end up with 1/3. And then when I do my antiderivative, I'm going to get 1/4 x to the 4th. And that's going to be integrated from 0 to 2. And so that's going to give me 1/12 times 16. 16 over 12, cancel out a 4, is going to give me 4/3, is the average value of that function on that interval.